Let me just check that nobody's out there and anything, and then I think the front's open anyway. So, all right, this is good. People are this late; they're not texting me; they're just SOL. So, you start it up?
Yes, it is.
Thank you very much. All right. So basically, today is the second half of the last lecture we gave. You weren't here, but basically we made a huge amount of progress. But the second lesson, the first full Python lesson we had, was clearly way over ambitious because we went through it really fast. I think everybody understood it, but we got about 2/3 of the way through that planned material. Plus, since then, I actually found some more material I feel is probably both entertaining and necessary at this point. So we're going to keep going through this, and then we'll see where we are at the end of this, and I'll come up with like I did last time, I'll come up with an assignment tomorrow night based on where we end up here. All right, and I'm going to start with a tiny bit of review. All right, so can we all see this? Do you want it a bit bigger? I want it a bit bigger.
Well, yes, that's
Yeah.
What do you think?
That's
Good?
better.
Is this good? I mean, who's got bad eyes here? You've got pretty thick glasses. See this? I'm very sympathetic. My eyes are slightly bent.
Yeah, that's what I have. It's on your web finder.
Oh, what you looking for? Can I help?
Just looking for bash or terminal.
Oh, yeah. If you want to imitate this, but I'm probably going to go too fast.
Cool, no, go ahead. I was just trying to get the same screen up. Don't
Oh, yeah. I'm probably going to go too far.
Sorry, yeah, I'm up. We're up.
Too fast for you. And you should notice. I hope you appreciate this. I'm using the least version of Python that anybody in the class is using. The oldest, dumbest version. So you're pretty well guaranteed anything I do will work for everybody. As far as I know, but I'm pretty sure everybody is at least 2.6 based on finding out what your machines are. So there's very little difference between all these. Right. So last time we went through a bunch of things. We went through numbers and operations. We went through strings. If you recall, the last lesson was called Python as a great desk calculator. So I demonstrated strings. We demonstrated lists, which can contain all sorts of different items. We talked about how to get, we had variables, so you can actually say, okay, let's let some variable named A do this. We have a way of getting things out of arrays, lists rather. You can also put things into a list. So we can do here, and we can do A. We have the concept of globals, which are all of the variables we've created. And of course, yeah, sorry, I'm not doing, oh my God, you know what I forgot? I forgot my spot. This is terrible. I have this thing called, I guess this is, anything damageable in here, John? There's a memory card in here. Does anybody have a small item? Small item.
Like a pin?
It has to be something you can kind of throw around or hand around, like a Nerf ball. You got a Nerf ball?
Oh,
Remember before I used that, and I like that a lot. Here we go. Here we go. Perfect. Okay.
Wear the mask?
You can wear the mask. I would actually recommend it. And then also remember, since you're answering questions, it'll really take the heat off when you're answering questions. You can be anonymous. So the idea is, if you remember, this is the spot. He's on the spot right now. I'm going to ask either questions where I hope you know the answer, and I'm going to give a bit of a pause for question. So if I get a question and you don't, the answer you have in your head is not the answer that comes out, immediately raise your hand. Immediately, right? As I said last time, I want to re-emphasize it. If you get lost on one concept, you won't catch up. We have to stay together as a class and be clear on all these concepts. And the way to do this is ask a lot of questions, because it's my responsibility to make sure you learn. Right? I'm the teacher. I'm getting paid for this. It's my responsibility to make sure you learn. And if I fail, it's going to be my failure, and I'll apologize to you. But the best way to avoid me failing is for you to say, so if I ask a question and the person on the spot answers a question, and if you get it wrong, remember it's my fault, so you should just blurt it out. And if you don't get a question, you should raise your hand. There's also guesses. I'm going to say guess such and such. That's something where I haven't taught it to you yet. But again, part of the theme of this course is Python has this concept of least surprise. Everything you do is supposed to be the least amount of surprising. So when you try something new, you should be the least amount of surprise you get. So when I ask a guess, again, the person who's on the spot gives the guess. But you don't have. If you guessed wrong, there's no need to raise your hand, because I haven't taught it to you yet. Okay, so, right, just wanted to point that out. Oh, and the spot moves each time we ask a question or a guess. The spot moves along, so it keeps you, somebody's always on the spot. And nobody's on the spot the whole lesson. Right, so far we have, let me get that stick, one more thing. And for people watching at home, oh. Well, I'm glad I did that. I closed that door. Voila, I have a nice stick today.
Where?
Yeah, I'll have a professional stick sooner or later. Okay, so we have numbers, we have addition, we have strings, we have lists, we have ways to, we have variables. So you can, this variable A has a list. We now have a way to get things out of lists. That's the third element in the list, because remember we always start counting at 2. We have globals, which is the list of all variables we've ever had. We also have dictionaries. Dictionaries are a way to map any immutable item, if you remember this, into anything you like. So you can say B is equal to A colon far, C colon 5, and this, we have a dictionary there, and we can say dictionary B of A, and that's going to come out, what's that going to do? Question?
4.
4, that is correct, pass it on. All right, and then we can say, here we go, B colon hello. Well, what's this going to do? Question?
It's going to error.
Yes, it's going to give you an error. And let's do something where we do B hello equals good. Well, I could use this mouse every time. So you do this, and it's kind of a question for you, but I know you're behind it. You can think of it as a guess. So what's going to happen when I print out B, when I display B? You can just throw it out. Don't worry if you don't get it.
Nothing, right? Because
Oh well, I just so the previous line was an assignment. So there, I actually assigned the string value goodbye in the slot name hello. Well, so just throw a guess out.
goodbye.
No, it's actually going to be that it's what we did is we assigned to the slot in hello. Pass it on. You assigned it to the slot in B. So we now have a new slot called hello. And now, if we go up to here again, now you can see that, what's this going to do? Question?
It's going to print goodbye.
Goodbye, pass it on. All right, so great. And there's a couple more things we went into last time, various functions. We had min, gives you things, that gets you the minimum. Oh, in fact, question, what's this going to do?
Give you 12.
12, fantastic. And that's right. And then we also have max, which is 45, very easily. And of course these work, just for you, right, oops. Oh, you can see a nice error there. You can see that also works with strings and this sort of thing. Again, it's the principle of least surprise. The maximum of something is going to be the dictionary maximum, the last thing you get in the dictionary there. So that's kind of a very quick review. Is this all? I know you can struggle along here. This is all. I hope you all remember this. This is all comfortable to you. All right. So now we're going to go. Today we're going to do two things. We're going to go into some more operations on these basic types, and we're going to also introduce a couple of more types of Latin, not quite as interesting, but still rather entertaining. So let's start with the most entertaining part, which is called slices. Now slices are really the first kind of fun thing you work out, and it's basically ways to take either strings or lists and slice them up, exactly as you thought. So let's start with a nice string. Let's call it S. I'm sick of A through B, and we'll make it something easy to use here. So what slice is going to do is let us pull out pieces of this willy-nilly. Pieces of this at will. There we go. I knew there's something I was coming to there. So things we can already say things like S0, which is who's got this spot. Right. S0 is going to be what? 1. Right. Fantastic. So the slice is kind of a generalization of the square brackets, which are called subscripting. Sorry, not a great name. So it's a generalization. I can now say S0 colon 2. So guess, what is this going to do?
Well, it's gonna 1, 2, 3, I guess.
You see,
Or
so
wait, 1, 2.
this is why it's a guesses. A very logical and interesting, but it only prints 1 and 2.
Okay.
And there's a reason for this. You had a question?
No.
Oh, okay. There's a reason for this. It has to do, I actually read up, and there's actually words about it from Guido himself, Guido, the founder of Python himself, about why this is. Basically, though, I decided not to explain it to you. The reason is that it's, once we start using it, it'll kind of become obvious to you why it's 1 less. It'll become second nature pretty fast, and the explanation wouldn't really do you any good at this stage. So the point to remember is that this 0:2 means everything including 0 but not including the 2. It's called what's called in mathematics a half-open interval. Now you can actually say something like, if you leave the colon out, you do something like 1 colon. Who's got this? Guess what this is going to do?
2 through 9?
That is correct. So if you leave the colon out, you can just, go to the end. That's very, very convenient. If I want to say something like, oh, I want everything from the 3rd element on, I just say this, and there we go. Fourth element on. Yeah, so for my English. There's also other things you can do that are awfully convenient. You can say the reverse. You can have a colon, empty colon first, and then say 0 colon, so just colon 4. And guess what? So remember what S is, of course. And we have S colon 4. And guess what this will do?
4 and under? 5 and under?
5 and under. Oh, 4 and under.
4 and under, yeah.
4 and under, yes.
0.
And it really, again, is because, remember, it goes up to, but not including the last position.
Okay.
Up to, but not including the last position. Sometimes you're like, oh, well, I don't know how far I want to go. I want to go 2 from the end. So you do things like S colon minus 2. So guess, what do you think this is going to do?
7, 1 through 7.
Absolutely right. And it's, again, that's the kind of the principle of least surprise. You're like, okay, minus 2 counts back from the end. A little bit surprising, but if it's going to do anything, it's very useful. And if it was going to do anything at all, that's kind of what you want it to do. Yes?
With the minus, a minus value being in the place where it is now,
Right.
is that still the -1, so it's actually -3?
Well, no. Let's put it this way. -1 is the last character.
Oh, I see.
Yes. So -1 is the last character.
Oh, okay, I get you.
-2 is the second last character. You can also put those at the beginning. You can say something like S -4 colon like this, and Eve, guess as to what this is going to do.
Start with 5.
Close. My guess is it starts with 6. We'll find out. 6, because it's the last 4 characters. Right? It's going to be the last 4 characters. Okay, so we have -4. So the position -4 is the 4th character from the end. Remember, I should add is, remember when you're doing work, actual production work, always experiment with these. It's very easy to be off by 1. There's a whole concept of off by 1 errors, responsible for many, many terrible, terrible problems in the computer world. Is always experiment. One of the nice things about Python is you can just drop right into this terminal here and experiment by hand and do things. I do this all the time. You get it right here, then you paste it into your code. So don't rely on your intuition unless you just have it rock solid. If you don't 100% know, then just try it out. It takes you 1 second. And remember, as I said, is the earlier you detect errors, the less work they are. Right. So the slice is good, but wait, that's not all. Slice also does some rather nice things. You can put a second colon in, and who's got this? Okay, this is a tricky one because I haven't given you any information at all. Just guess. What do you think that's going to do? All of you think for a second. What do you guess that would do? We've added another colon there. Just guess off the top of your head.
I don't know, it's going to do 2 different operations. The first one is going to give you the whole list, and the other one up to 2.
Oh, that's not a bad idea, actually. But no. I mean, it's like a pure guess. You want to know. No, what it does is it does every other element. Every other element. So if you do this, we're going to get 1, 3, 5, 7, 9.
So 2 dots, is there gonna,
So the second colon, so there's actually three, the full syntax of the colon is going to be things like 0, 5, 3, right?
Oh, that's the, I was just messing with that.
Yeah, so that's the full syntax, but you can sort of leave some of these out. And this one goes only 1 and 4, for example. Question?
Yeah.
Yeah, why did it do just 1 and 4?
Well, it's straightforward. It says the first one, the first element of the colon is where you start.
Oh, yeah.
The last one is where you end, and that one is the skip, how many you jump by.
Gotcha.
So it goes 1, then skips 3 to go to 4, and then skip up, and it's off the end. So let's do something a little bit daring. What happens if we do 5:0? Who's got that? Who's on the spot? Guess. Guess what you're going to get.
5 and 1.
No, you get nothing at all. It's empty. It's empty, and it kind of makes sense because basically is you start at 5, and then you increment until you get past 0. Oh, you're already past 0 before you even start. So it's an empty slice. And slice it, so, and you're like, oh, well, that's not that interesting, but it's good to know that when you slice, if you slice beyond the range, you slice way off the end, or below the beginning, or you slice things too short or too long, it'll always fill it in for you. You'll never get an error with the slice under all any conditions.
But that would be a false.
What?
And that would be interpreted as a false.
Well, it's interpreted as an empty string, which is false E.
Yeah.
We haven't got to true E and false E. Truthy and falsy yet, but we'll get to that in a bit. But still, you may actually want to go backwards. So guess what's this going to do? I gave it away there, but...
5th position, stepping backwards by 1 to 0.
And that is correct. Almost. What happens here is that, remember, is that ending, the ending is always 1 before where you actually stop. So if you really wanted to do that, and perhaps that was cheating, you just put a blank in there. Oh, right, so it starts from
You
position
wouldn't put a
5.
-1 there.
-1 at the end. So
Not at the end, I'm talking about the middle.
Oh yes, that's true. -1 in the middle would also do that. That's very true.
Ooh, no, it didn't do that. That's interesting.
I didn't do that, and I have to say I don't understand why I didn't do that. I'll find that out for next time. So that's kind of a shock to me. I expected that to work, but it doesn't. Fascinating. There's a reason for it. We'll find it out. But usually you don't. You usually just put it blank anywhere there. And of course you can do things. You can skip by -2, or you can start off at the end, at the last character and go backwards.
Yeah, I actually played around with this for the homework, and I think I came up against something just like this, and it did not give me the result that I expected, and I must have done something wrong because I did it exactly the same way, and it gave me yet a different result. Does that make any sense?
No,
So I
not
must
entirely. It should be stuff like this is very basic.
Right.
It's got to be consistent, or thousands of people would be complaining. It's probably used in almost every Python program. You can generally assume there's an old saying that says it's not a compiler problem, because it's a thing people do. They get very bizarre behavior out of their program, and the compiler must be broken. In fact, I knew somebody when he worked at Google who was actually an expert on the C++ compiler, and he found several problems with the C++ compiler because he was getting the most difficult problems from about 1,000 engineers who were at the peak of their skills. So he was only getting the problems they couldn't solve, and even in that case, he solved 99% of them, but 1% of those would actually be. You're not going to run into these at your level.
I must have done something wrong.
Yeah, I mean, wrong is you're exploring. I don't think wrong is like a kitten falling off a pillow. Where it's like,
I've seen that happen.
Yes, we have a kitten. We have a kitten at home now, so which John got to visit yesterday. So this isn't an abstract example. So this is slice, and there are going to be quite a few homework questions on this. None of the ideas are too tricky, but it's just good to practice it to get into. And I should point out that slice, like everything else, doesn't just work on it doesn't just work on strings. Slice can definitely work on arrays, and you do this all the time on lists, rather than call them like on lists. I've got to keep using the correct term. So that's very handy. And all of the same stuff you use, you just learned on slices of strings will work on lists. and some other things you'll run into in the future that are linked lists, which we'll get to in this lesson. And remember, so let's just to quickly review. Remember, we have the beginning, the ending, and the skip. So that's from begin and skip. Remember, you always go to one before the ending. One before the ending. And part of the reason is, it's pretty, one straightforward reason of this is, here, who's on the spot here? What's this value going to be? So remember the len operator, which I didn't review, but
Right.
gives you the length of either a string or a list.
It's gonna be 3.
No,
Am I wrong?
you're wrong.
Oh, jeez.
No, in fact, the reason is, the whole reason for the, one of the reasons for the off by 1 thing is entirely so that length is 4.
Okay.
If that went all the way to, if that included position 0, 1, 2, 3, 0, 1, 2, 3, 4, that would be 5, a length of 5. You want to slice 0 to 4 to be of length 4.
It's 1 minus, is that?
So that's why that little off by 1 thing. Again, there's a long article actually by Guido defending his decision to do this and saying, I could have gone another way, but I didn't. And he pointed out how when you're actually doing long programs and things, this works out much, much better. For example, if you want to slice, here's a classic example. But here I have S again. Remember S? So supposing I do S colon 4, right? And then I also do S for colon. No, that's exactly what if I didn't knew how to type. Okay, so these two slice up the whole string. That's a very big reason why they're the same. It's because you really want to be able to do that, otherwise you constantly have to put +1s or -1s in there and you screw up. So that's really another key reason why the end of the slice is 1 before the number on the end. Again, I hope you get this, not complete confidence you can use it right now, but at least the understanding of how it's put together. And once you experiment, you're like, okay, this makes sense. There's only one sort of way to do it. Okay, so now we have slices. Now I think the next thing we go to before something a bit dry. I spent some time thinking about this. Which do I want to do? Okay, no, we're going to go to what's called list comprehensions. Another not entirely exciting name. But this is one of the things that makes Python really slick and easy. If you recall, before we learned for statements and such, right? So we have things like for example, we have things like for I in range 5, print I, and that prints all of these items. And let's supposing, for example, you wanted to create a list of the first 10 squares. So you might say something like squares is an empty list, and then we do the following. We say for I in range 10, so that's for all the numbers between 0 and 9 inclusive, right, if I like to type. Then we're going to say squares dot append I. Okay, and who's on the spot?
I am, but
It's okay, as I said, you're missing a class, so
Right.
You can just guess, consider this a guess, but everybody else is, well, this is probably a guess for everybody. Okay, so I did something here where I started off with an empty list, so the list is empty, and then I said for I, between going from 0 to 9, and again you see there's a thing where range 10 stops at 9, exactly the same reason. You want to have 10 items in range 10. So for each of the, right. And of course I didn't do this right. But still, well, now let me do this right actually. I wanted to do the squares. So let's, and I didn't do the squares. Squares. Oops. All right. So guess for you, guess for everybody. What squares have in it now?
I don't know.
Right, that's an answer. That's a pretty good answer. And, I'll just show you here. It's the squares of the first 10 numbers,
Okay.
0. Right? So in other words, what we do is we take For each of the, this little loop here is going to execute once for each value of I in this range. That's 0, 1, 2, blah, 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 9. And what it's going to do is append to that list I times I, the square of I. So that's why we get a list now, 0, 1, 4, 9, 16, 25, blah, blah, blah. Right, please.
Before you did the for statement above, did you have to define I?
No, no. In fact, I is only defined within that for statement.
Okay.
Although in early Pythons, I actually does have a value. That's an error, that's a mistake. That's actually a known bug in Python. Really, I should only have what's called scope. It should only really make sense within this range here. So you don't have to define it. This actually defines the I in the process of assigning it. Yes?
Well, the first time when you didn't do it as a square, squares dot append I,
Yeah.
did you delete those values?
Yes, look, I did delete those values there.
Oh, okay.
I reassigned it.
I was wondering why it didn't
I
show
reassigned
up.
it. I should have made a bigger point about that. Yes, it's absolutely true. I cleared it out by reassigning it to a list.
Squares, so you just define squares again.
I redefined squares again. Perfectly, you can do that as many times as you want. Absolutely free. Okay, so there we go. We have this, but it's kind of a bit clunky to do this, you know. Or it's like, this is what you do in a lot of programming languages. You set up a loop and all this sort of thing. But it's kind of a lot of typing for this one concept. It should be very straightforward, and particularly, you're doing things with lists and iterations all the time in Python. You'd like to have a better way to do it, and that better way exists. It's called list comprehensions. List comprehensions, and I'll show you how they work. So we're interested, I'm going to keep hitting this caps lock. I times I for I in range 10. Who's got the spot? You do. So guess what this does? Even though I'm probably giving it away. This is a guessing.
Oh, it's gonna take all those values and it's gonna square the squares.
Well, no, because remember, no, I'm not even using squares. You see that this is a brand new statement here, right? You see, I'm not referencing the previous value. So
Right.
this is virgin tabula rasa, you know, whatever, blank slate, anything else you like. So, well, what's going on here? So this is what's called a list comprehension. Basically, this is these three statements split into one. So what it says is, this for statement within there says, go through all the values of I between 0 and 9 inclusive, 0 through 9. And the actual value I'm going to put in this list is I times I, square that number. So what's this?
It's gonna print the same thing that you got.
And yes, very good. So what do you think? You're looking a bit puzzled. You're not actually puzzled, you're saying.
No.
Okay, this is good. Are you puzzled?
Not so much puzzled as like, not puzzled, I mean, I understand that, but it's just that it feels like it's like kind of hard to, like, if I looked at it like first blush, I would have no idea what that would come out.
That's very, very true. It's not necessarily, well, it's not intuitive, but once you see it, once you've seen it a bit, it becomes much more intuitive.
Yeah.
It's a very, very handy way to do a lot
Well,
of
that way you can generate your values very quickly as opposed to adding all this code.
Yes, right, exactly right. And it doesn't, you can also use this for operations on dictionaries, operations on a whole bunch of things, as we're about to see immediately. Nobody's gonna fire you if you use this mechanism all the time. If you're not comfortable with these list comprehensions, if you use this syntax, no one's gonna fire you. But you're going to find after a while, if you use this, it's just going to save you a lot of typing. It's going to save you a lot of possibility of mistakes. Like there's a whole variable here, squares. It just doesn't even exist there anymore. You don't even need that variable. Nobody's going to fire you for doing the equivalent list. And there's always, for each form like this, there's always a form like that. So you don't have to do the list comprehension, but I recommend it. It's much faster way to go, and there'll be quite a lot of exercises on this too. And so this is pretty trivial. What about other things? Well, what other things can we do? Well, let's go back to dictionaries here. Let's create a nice dictionary of, let's say, my name, and I suppose my phone number is 23, and let's see, Lippy's name, and his phone number is 42. Great. So I can do this comprehension such to get stuff out of dictionaries as well. Like, here's a very good example. I can simply say D, I, for I in D. Who's on the spot? E. Okay. So we have some dictionary D that has names, maps names to phone numbers, very short phone numbers, like maybe an internal directory. So now this is a list comprehension that says, go through all, now if you remember, for I in D, where D is a dictionary, goes through all the keys in the dictionary. Goes through all the keys. Remember, the keys are these things on the left. These are keys, Tom and Lippy. The values are 23 and 42. So for I in D goes through all the keys in the dictionary. So this actually says, look up, for each key in the dictionary, look up the value of that key in the dictionary and put it in there. So what? Who's on the spot? Oh, did you? Weren't you on the spot last time? Did you pass it on? Whatever. Answer the. Guess what this is? It's another guess.
23 and 42.
That's probably correct. Ah, you see, it was in a different order. Why is it in a different order?
Dictionaries are unordered.
Very good. Dictionaries are not ordered. As I said in the last thing, dictionaries aren't ordered because most of the time you don't care. Sometimes you do want dictionaries to be ordered. There's something called the ordered dictionary, which it doesn't happen to exist in Python 2.6 actually, but you can just download it and put it in. It's very easy. So you don't know what order. You have no idea what order the keys are going to come out of in a dictionary. And that's actually very good because it would be quite inefficient to keep your dictionary if you had to sort them as well. So your default, but it's usually never a problem. And since there's so many easy ways to sort things, when you need to sort it, you will. So your answer was right there, by the way. I mean, just they tend out in a different order. So that's very, very handy way to do things. You can also build dictionaries using this. And this is a little bit trickier. So let's watch, notice nothing in my hands. I would pull my sleeves up. Okay, so we're going to say dictionary I, comma, I times I for I in range 10. Oh, right. This is a tricky one. This is definitely a guess.
Alright, so for I in range 10, which means 0 to 9, the squares and the squares placed at, they're going to be placed 0 to 81, and it's going to be in order?
Well, that's kind of true. Look at you're doing pretty well, except that notice there's a dict at the front, so we're building a dictionary.
Yeah.
So what am I going to get? You're close.
You're going to get a list.
Well, I know. I'm definitely going to get a dictionary out of this.
Yeah, but what do you mean? Oh.
Right. So the result is this is why this is a guess, not a question. Right?
Everything's going to be an index. Well, you're going to get a dictionary. You're going to get so you're going to get 0, 2 dots is equal to 0, 1 is 1, 2 is 4, 3
Absolutely
is 9.
right. Fantastic. There we go.
Right. Now, is that dict is that a keyword?
That is a type. It's a type. It's actually, or you can think of it as it's one of the basic functions that's built into.
So you can't just use anything there.
No, dict is a special word, actually.
Right.
You can think of it, it's not quite a keyword because I can, if I wanted to, I could actually say dict equals 5 and keep going, if I wanted to. So it's actually a variable like any other. I couldn't do, if I do something, like, some things are actually keywords. If I do 4 equals 3, I'm going to get an error.
Okay.
I know that if I type dict equals 4, I would not get an error, but I'm not going to do this because it would break the rest of my thing. I mean, I don't All right, I gotta try this. This dict equals 3. Oh, no, dict equals 3. So this definitely works. Now, the question is, now the previous example isn't gonna work, because dict is now the number 3. So let's see what happens if I do delete dict. Let's hope that this works. Oh, there we go. So that did work. So this isn't really, dict isn't, this is kind of a sidetrack, but it's good to work out all the answers. Dict isn't really a keyword, it's a variable that's pre-assigned for you.
I see.
And there's a lot of other variables like this, globals as well. Globals is a built-in function, like dict is a type, but I can actually say globals equals 4, except I can't use the globals anymore, right? In the same way I can, but I can then del globals, and it will all work. So there's only a very, and that's kind of nice. You're initially like, well, why would you want to do that? I could get into trouble. Well, there's a very, very large number of things that Python has built into it. And if you had to remember all of those, you'd go crazy. So it's kind of fine. If you use dict consistently in some little section of your code as a variable, who's to stop you? So there's only a small number of actual keywords, things like for, if, else, def, class, when we haven't studied yet. Those keywords cannot be used as variables. Pretty well anything else can be used as a variable, even things that are predefined by the system. So, and that can actually be helpful. You can do really sneaky, obnoxious things where you're trying to debug some code, and you're like, okay, I'm going to assign dict to my own special function that checks things out for you. So it can be really handy to do this sort of thing. I do this all the time with, anyway, I do this all the time. Okay, so these are comprehensions. Now, there's another way to use comprehensions. It's ultra fancy, and in order to do this, I'm going to have to introduce a new type. We haven't done a new type. Remember, the types we have up until now, we have, who's got the mask? Well, let's see. Let's see if you can name all the types that we have. Things like string. I guess this is kind of a question, but it's a really long thing, so don't worry if you miss some. And all of you, try and think of all the types we've run into in the previous ones. Just stop loading them out.
Single quotes and double quotes, is that?
Oh, well, those are the same type. Those are both string. Okay, my question was poorly formed. I'll list them for you, and then you'll know what the types are. And then the next time I ask this, it wasn't a well-formed question. I'm sorry about this. So we have the following types. We have strings, right? And we have both double-quoted strings and single-quoted strings are the same type of thing. And actually, there's a way to find the type of something. We can do the type. It's a type operator, type function that actually tells you the type of this thing. It's a thing of type string. We also have numbers. We can say type 1, that's an integer, int. We can say type 1.0, that's a float. We have also lists. We can say type of square bracket 12 to 23, and that's type of list. And then finally, we have type of 1:2. And who's on the spot? You get to ask this one. What's this going to be? Guess. Okay, the type of this. So this is the type of this is the last type we did last time. It's dict. Dict. Right, and it turns out that, so the types. And let me jump back. I clearly am going to. I clearly jumped somewhat ahead here. Types are the way that you assign. It's sort of an object with behavior. So, in other words, an object glued together with a bunch of methods, a bunch of operations that work on it. And so every time I say, oh, that's a float, oh, that's a list, oh, that's a dictionary, that's kind of shorthand to saying, oh, that is an object of type int. That is an object of type float. That's an object of type dictionary. Does that kind of make sense? You're still looking a bit puzzled.
Yeah, I'm getting the integer to float. What's that?
It's a name for all of the operations that are on that.
The others you put in the numbers and it gave you the name back. So this one you put in it gave you back the type.
Yeah, so that type function, built-in function called type, just takes an object, no matter what it is, and tells you what type it is. And then that type, in turn, tells you what operations are permissible on that.
Oh,
You know, it's the same way you might look at I mean, in the real world, you do this all the time. You look at a watch, and you're like, oh, this is a tight watch. I guess nobody winds watches anymore, but for what used to be, I'm like, okay, I can wind it with the stem, I can pull the stem out and change the time, and this sort of thing. So you know that, and you don't try and do the operations you might do on type Apple. You don't try and cut it up and eat it, and things like this. So you instinctively understand this sort of thing in the real world. And in the programming world, you probably, it's kind of the same sort of thing. You wouldn't actually try to, I don't know. Well, yeah, I guess at this early stage you don't have the instincts, but still, it's the same thing in the programming world. Is the set of operations on an object is defined by its type. And well, you can ask me again if you're still fuzzy after doing some of this. Okay, so this is I think this is the only type. Oh, there's one more type. Here we go. You've got this. Can you guess the one type I forgot to mention?
I was gonna say, well, Boolean.
Got it in one. Absolutely. Very good. Booleans, and then what's a Boolean? I think I mentioned this before. Boolean is a kind of fancy word for true, and values either true or false, named after Gerard Boole, a English mathematician, like 18th century, who first came up with the idea of doing logical operations. And we can easily find one of these. We have type of false, and that's type bool, short for Boolean. So those are all the types we've learned now. We know about strings, integers, floats, lists, dictionaries, and booleans.
Other types as well, but okay.
And we're about to learn about some new types.
Groovy.
Okay, I'm just going to quickly go through a simple type to get us going. This is a type called set. And here we go. We say, let's say set 1, 2, 3. Actually, kind of annoying about the syntax here. All right, and that's not very interesting there. So the first question is, you have, well, why the multiple square brackets there? Well, basically is, what set does is create, no, in fact, I'm not going to answer that question until I explain what a set is, and then I'll explain what a square bracket is. So what is a set? What's the difference between a set and a list? Well, perhaps many of you, some of you remember in your childhood days, you may have run into something called set theory. Did they teach that in schools? To kids? Oh, okay. It's interesting, I went through the new math as a kid, so they taught you all this stuff. I don't know if you know Tom Lehrer, who did a great song about new math. And what a set is, just a bag of objects. No order to it, and there's no repetitions. You can't do repetitions in a set. So, for example, if we have S equals, let's say we have S equals S. So we have this set here. Let's do S dot add 5. Now I have a set with 5. Let's do S dot add 5 again. Who's on the spot? What do you think we're going to see?
1, 2, 3, 5, 5.
Well, but no, but sets have no duplications.
So they
Oh.
unsorted and unindexed?
They're unsorted and unindexed. Very good question. So if I do S0, pass it on. We get an error, right? Look, it says this is the example of a nice error compared to some of these. The set object does not support indexing. There we go. You know, since you know this is indexing, it says very clearly what it can't do because it's unordered and it has no repetitions. Well, what use is this? It's incredibly useful for when you really just want a bag of elements. Right? A lot of time you don't want repetition. What you do want to do is be able to tell very quickly whether an element is in a set or not. That's a very, very common thing. You're like, okay, boys here, girls there. You have a set of, boys equals set, Tom, John, and, oops, right? So the question is, did I get this right, I think? So the question is, I want to know very, very quickly whether, let's Tom in boys. Is Tom a boy? Absolutely, Tom is a Tom boy. And but is Eve in boys? Who's got the thing?
False.
False, yes, very good. And the thing about this is that list, you're like, oh, but wait a second, doesn't list let you do that? Let's supposing I say, boys, is just the list. Here? Right, so now we've just made this a list. What do you think this is going to do? Yes.
I mean, I guess it's not going to say false.
No, it definitely says false, so it gets the same results. It has the same result there, right? So, and you can do that same in operation, containment operation. So, what's the advantage of a set? Well, there's two advantages. One of them is the lack of repetition, but the other one is the set is much faster to look things up. In a list, you have no way to find anything in the list without walking through all the elements in the list. A list might be very, very large. So if you have thousands of elements, if you do the in operation, it has to go through all of those thousands of elements. However, sets use this magic called hashing. It's the same thing that makes dictionaries work to allow this to operate much, much more quickly. So, so sets turn out to be very, very handy when you have large collections of things where you want to say just you only want to answer the operation is something in that set. So those turn out to be very, very useful. So the final question is why this? Why the square brackets? Why don't I do this? Like this won't work. Look, we get an error. Oh, and again, it's nice. Some of the errors we've had before aren't very good, but this is a nice error. Set expected at most one arguments. At most one argument. Let me just have a parenthetical notice. If you see one argument or anything in code, I didn't ever write it, okay? I never allow this to happen. Terrible grammar mistake, but it's still clear enough. The set expected one argument, it got two. But why? Why can't you just say a set with all these elements? Okay, the reason is that what a set is actually expecting is any list-like thing. It turns out it's going to expecting something called an iterable. This is your first encounter in an iterable. By the end of today's class, you'll know what iterables are. But informally, iterables are things that can give you a series of values. So sets don't just, you can actually create a set with some operation that's still ongoing, that's popping out values for you. That's kind of why, piss off. Excuse me. There's nothing to back up here, you know this. And that's, so you kind of lose you lose a little bit because the syntax is a little bit unexpected. You would prefer when you get started actually to see this syntax. It's much easier. You have to put those square brackets in. That's annoying. But the advantage is that later on in life you're going to be constructing sets out of all sorts of fancy things, all sorts of iterables, and everything will flow through really nicely. You won't have to make any changes. But here's a classic example. Where's our last dictionary? We have square. No, squares is a list. Here we go, D. So D is a dictionary. I can just say set D, and that is the set of all keys. Because remember, when I iterate over a list, I get the keys. This part I'm not expecting you to quite memorize here. This is kind of just why I feel a necessity to explain everything that's not obvious, or at least to indicate there's a reason for it. So you don't necessarily have to remember the reasons for some of this stuff where I explain here's a reason for this stuff. Okay, so sets, that's kind of it for sets. They do this one thing, testing for inclusion, they do that really, really well. So a set's very straightforward, just does one thing. Here's a bunch of items. Does it? Yes, Steve.
So is D now, it's now a set, not a list?
No, it hasn't changed. Remember, in order to change D, I have to start off D equals something.
Okay, so.
In order to be assigned D, I have to start off that. So no, that's just, again, like as usual, this is like a desk calculator. It just prints the value of everything that I do. So the value of that last operation, set D, is this set. Okay, so sets are kind of dull, but the next things are more subtle and more interesting. They're called tuples. Tuples. And again, another terrible name. And what's a tuple here? Well, let's say T, and that's equal to 1, sorry, it's not a 1, 2, 3, 5. Okay? And we have T, and we have, looks a lot like a list, doesn't it, right? right? Oh, can we slice it? Let's give it a try. Let's do T1:2. And who's on the spot? Eve. What do you think this will do?
2 and 3. Or just 2.
Just 2. Very good. Very good. That's exactly right. So it's and you're like, wait a second. And I did this really. What's that trailing comma there?
Yeah.
Well, again, this is another minor awkwardness. Is the reason that this value here isn't a tuple, it's just the number 2. This value here with the comma is a tuple with one element.
How do you
I'm-
spell tuple?
Oh, tuple. Tuple, 1, 2. Right? Or another way to do this, you say type of 1, 2. That's the type of tuple.
I'm sorry, I think this is a basic question, but
Yes.
can you go back and just explain again why there's nothing after 2 for the T1:2?
Oh, yes, it's because, remember, the counting always stops 1 before the
One
last.
before, right, okay, yeah.
Right, and the reason for that is so that the lengths, it's a bunch of reasons so the lengths work out right, or so if you slice, colon 4 colon, you get just the string sliced in 2 parts. That's why it's called a half open. It's open at it's open at the back and closed at the front. Half open, as they call it. Okay, you're like, well, what's the point of these tuples? Why do we care about tuples? Well, it turns out that tuples have some advantages over lists. The number one thing is the following. Here we have got this tuple T. Supposing I do T1 equals 3. Well, I'm not going to let you guess here. We're going to get an error. We get an error here. You're like, tuple object does not support item assignment. You're like, oh, well, that's bad. And what about, let's try to append something. Let's do T.append 3. What do we get? Oh, we get another error. It has no attribute append. And actually, if you try to do things to change a tuple, you will fail. There is no way to change a tuple. A tuple is what we call immutable. If you recall from the last class, immutable means something that can never be changed once it's created. So, for example, strings are immutable. You can't change a string. I can create new slices out of that string. I can take pieces out of it. Question?
What's the difference between append and add?
That's a very good question. And let me temporarily, what we call stack where we are, and I'll go back to it. So you notice something interesting that I probably should have pointed out even, is that somewhere up here I added to a set. Well, anyway, somewhere scroll back, I added to a set, but I appended to. And actually, this is a very good distinction. Append specifically means append to the end of something. Add this to the end of some list or whatever it is. Sets have no order. Append doesn't make any sense for sets. Add makes sense because you're just throwing it in this bag. So remember, a set is kind of an unordered bag of things. So to append to this bag makes no sense. But a list is actually a sequence of objects. To append to that item, to a list does make sense. But tuples don't let you append, they don't let you add, insert. There's an insert on lists and things which we may deal with. But I'll probably say that as an exercise, come to think of it.
So they can be used as keys.
There we go. Well, Lippy's got a huge book on Python, so he has a huge advantage here. But yes, so you're wondering, why do we want something that's deliberately crippled like this? And the answer is, well, it turns out to be ultra useful in a bunch of reasons. And the number one reason we'll learn today, there'll be more, is that you can use them as keys in dictionaries. Now, as I mentioned last time, I do want to reinforce these. The key to a dictionary has to be immutable, has to be something that can't change. And the reason is because if you put something in a dictionary and then change the key, what happens? Does it stay in the dictionary under the old key, or does it move locations? Both of those would be really, really bad. But one thing is they would be bad, and it would also make it very, very difficult to implement a dictionary properly, because a dictionary would have to be watching all of its keys to see if they changed and then do something. It would not fly. The dictionaries would be too slow to use. So Python, and as I think I mentioned last time, is C++, for example, does not enforce this. It is a cause of numerous subtle bugs in people's code where they change the index into the key in a dictionary for an item, and then they try to look that item up. And depending on how they do it, they get different results. So like, well, what happened? Well, you changed the key. It's a classic error, but C++ doesn't prevent you from shooting yourself in the foot this way. Python does. So often, but you will often want to do something where you actually want to look up something based on multiple numbers. Like you may, here's a really contrived example, but we may say, we want a dictionary where you say, let's to tell, maybe we want to do a reverse telephone thing, where we say something like 917, 449, 8191, that's my phone number, by the way, don't abuse it. Right? So that's kind of a reverse thing where I'm looking up from my phone number divided into parts. And I can actually create such a dictionary. And that dictionary maps this tuple, this tuple of numbers, like a list, to my name. If I tried to do this with a list, I would get, who's on the spot? This is a question. What would happen if I do this?
Tom, then your number?
No, get an error. Again, it's because, remember, and it gives you a reasonably clear error here. I'll explain it once you understand it. You can't, remember that keys, again, is lists are mutable. I could take that list. For example, I could say here, I could go back and say, oh, a little far, I could say something like a number is equal to this list. Right? And then I could say telephone number is number here, if this actually works. I can error, but if that worked, I could then go back and say number 0 equals 212. I could change that key. Right? I could change that key while it was actually sitting in a dictionary. That would be really bad, because it would break my dictionary, it would no longer work. You want to make sure that in a dictionary, all the keys are immutable, they cannot change. That's the main reason for a tuple, and it turns out to be ultra handy, probably 2 or 3 lessons from now. And there's also other reasons. Tuples end up being used in a lot of cases where you need to have a series of items, but you want to make sure that this can never ever change. We'll see more examples coming up, but this is a primary example.
So tuple, I mean, when I first read it, it sounds like it refers to some sort of 2 or 3, but it doesn't have any sort of quantity. It's just a sequence.
Yeah, it's just a sequence. It's a mathematical term. In fact, you say in mathematics, you say things like, here I'll put in a comment. You say 3 tuple. That means a tuple of length 3, or n tuple. People say that it's a very common expression. N tuple, a tuple of length n. As I said, it's not a great term, but a lot of computer scientists know what it is. You're just going to have to memorize it. Not so bad. So these are some new types. Not as exciting as the other ones, but they do lead us to something rather interesting, which is the generator. I think we ran into a generator by mistake the other day, and generators are kind of one of the first really snappy, almost unexpected things you get here. What a generator is a way to specify an element in a sequence without actually generating them all at the time. Let me give you an example here. Let's call gen is equal to I times I for I in range 10. Now, we already saw something like this with square brackets. If you recall above, we did something where we said, with square brackets, let's make it to the end, but anyway, we did this before. This is the thing that actually goes through that. So with the square brackets, this is called a list comprehension. It actually produces a list. So let's print out gen. What do we get? We get, generator object. What the hell is that? Well, what this is this is something that's like a list, except it hasn't computed the values for you yet. The values are waiting to be computed. But I can still do something like this, where I say, for I in that generator object, print the value of I. And it prints all of those squares. It doesn't, the difference between a generator object and a list comprehension is that the generator object doesn't compute the values till you get to them. And you're like, oh, so what's the difference? Well, first, I should say the other difference is, remember, notice is square brackets are list comprehension, and then round brackets, like these ones, make for generator. And you're like, well, what's the advantage of this? Well, let's try going back, and let's say for I equals range, let's do something like that. Oh, look at that. So I can't do range a gazillion or whatever it is. That isn't going to work. But if I do here, if I do this, then I can actually say gen. Oh, right. So there we go. I can. Sorry. Voila. Now, what's going on there? Why did I have to make this change? Well, here's why. And there's a new thing we're introducing called range. This was a mistake on my part. Why am I having to make this change? Well, the problem in this first one, I couldn't create a list this long, but actually, if you recall, range creates a list that long. Anyway, right? So if I just type range, like this, that gets an error, but x range with some long number. What I get is an x range, which is another generator. It's another thing that instead of computing the values you have, will pop out the values one at a time for you on command. So I can actually have an x range 1 billion. In fact, you can have generators that are unlimited, right? That actually have a potentially infinite number of elements in them, which can be very, very handy. And you're like, well, why? And the answer is, well, you can still do operations with them. I can say, for example, for I in x range, whatever, this huge number, I can do print I, and then it's going to just keep printing as long as I like. And often you want to do something, though, where you're looking, say, for like the first number that has a certain property. Well, you can't do this with a range, because you can't have a range that comprises all numbers, but you can certainly do it with an x range. So the idea is behind generators. So let's see, we have this generator again. Let's actually take a look at this one. We can say for I in gen, print I. So it's going to start printing the squares. So we're printing squares very quick. But the interesting thing is that if I start this again, it actually starts, well, it's a little hard, it goes too fast. I don't start from the beginning again. Let me do it with let's do it with a much smaller number here, so we can actually see this. Let's do this with x range 10. Okay. So this prints the squares when I do this. Very straightforward. But now let's do this again. All right, who's on the spot? What do you think is going to happen when I do it a second time?
Nothing.
Nothing. Absolutely right. So why is this nothing? Well, because remember that this is a generator. It's just something that spews out numbers till it's done.
And then now it's done.
And then it's done. And that's actually also really, really handy. You often do want things that are like this, that aren't like lists, because you just want to go through things. Maybe you want to pass this somewhere else, pop a few of these things off, do this, and then you're done. You just want to be done. With a list, you don't know where you are in this sort of thing. You could keep taking a list and slicing off the front elements. That would be expensive. You'd have to make new lists every time one would do lists. With this, it just keeps giving you numbers. And you're probably going to find, particularly when we get later on in the text processing, when we're dealing with very large things like the natural language toolkit, almost everything you get out of there will be a generator. In fact, it's true also if you read my very late night message about using the Google App Engine. All the time on the App Engine, you're actually doing queries from the App Engine. You're actually getting data from that you've stored previously. Well, you have no idea how many of these things are. The App Engine lets you make unlimitedly large applications. So the results of these queries are also a generator. And in fact, each time you get a new element, at that point it goes out to all these Google machines out in the world and gets a new element from those and gives it back to you. Generators are kind of the first subtle concept, but they're really a lot of fun because they let you do things that would just be otherwise completely impossible. They let you deal with very long things that are like lists without storing all the elements for lists. Let's take a 10-minute break, and then we'll get back to this. I'll grab this.